Cool. 730. Count different palindromic, palindromic subsequences. Given string S, find the number of different non-empty palindromic subsequences in S, and return that number modulo 10 to the 9 plus 7, which I guess is a prime. A subsequence of a string S is obtained by deleting 0 or more characters from S. A sequence is palindromic if it's equal to the sequence reversed. Okay. Two sequences are different if there's some I in which A sub I is not equal to B sub I. I guess that means that that they could return the same string, but they used the different parts of A and I guess, something like that. Okay. Yeah, I mean, I think so. The first thing that leaps at me is that if you have to return a number modulo 10 times 9 plus 7, that means it's a combinatoric problem. I mean, I guess that's also the find the number part. But so it's a combinatorial problem, and usually these are dynamic programming without even reading anything else. But obviously, that's not the hard part. I mean, like just saying something is dynamic programming doesn't mean you solve it, and your interviewer would be impressed for half a second before like, okay, now what, right? Okay, oh, way to hide that in there, which is each of character in the S sub I in the notes, which is like after two examples. Why don't you just put it on the top? I don't know. But anyway, each character S sub I will be in a set A, B, C, and D. So it's a four. Again, it's a four-character alphabet. The length of S sub I or S is okay. So S is less than 1,000 strings. Okay. Okay. I mean, so yeah. So it's definitely dynamic programming, but the question is how. Dun, dun, dun. And they have this one big example that I don't know. I mean, it tells you the numbers, but then here, okay. And each of these, and it could go up to 1,000. Yeah, I mean, I think. I mean, it's definitely dynamic programming. I think the intuition for me is maybe it's a little tricky. Is that basically your map would be n square. You basically have a table, a lookup table, an n square table, which is a million, and that's most, and that would be your substrings is your subproblems, and yeah, I mean, I think the function is just, I mean, there's a couple of cases, and that's how we have to consider it. But I think you have like, okay, given a string s, give, s, so how do you construct a palindrome, right? So you, for example, let's just say B, C, C, B. The first way to do it is, okay, well, let's say you take off the B's on the edge, right? So this means it's something like, so f of this is equal to the summation of some other stuff, right? Which is like, let's say you take off the B in the edge, or you take it off and it is part of the string, and then you also have to count that it is not part of the string. So I'm still trying to formulate this in my head, but let's say something like this, and then is that even true? I don't know. I mean, roughly. I mean, we have to figure out the different cases. I think that's probably the tricky part about it. And then, and you kind of glance from the example. Actually, I think this is a very, BC. Oh, that. Oh, actually, huh. Actually, I was a little bit wrong about. Wait, am I? Why is this only counted once? two sequence different if there's some I which I misread this one. Okay, so yeah, okay. Anyway, I mean that's just edge cases, so we have to figure it out. It's going to be a tricky one, and then this one we have stuff in the middle. You could say, well, either we use O of FCC, and then maybe F of, and then you maybe just ignore the first character. So, in this case, maybe you something like that, and then maybe also even have a PCC or something like that. Some combination. Maybe not quite like that though, because you have to have some sort of ordering to it. Otherwise, some of these will kind of double count in some ways. So I think there's definitely a lot of things I have to be careful about here. So maybe something like that, and then try to think about how to quite do it. I think actually, I think so. So there's definitely some way of constructing this, but I'm also kind of, in terms of giving bounds, and some of it in the notes is kind of maybe hints, and that's what I would kind of maybe think about. Is in this case actually, I think the interesting thing is that each character of SFI should be in the set, right? And even though it's something to glance over, I think what in some of these problems, it's important to solve the problem as specifically as possible. And what that means is, in this case, like we're doing this like really generic string thing, maybe it's too easy, right? I think the thing we can maybe figure out how to do is reframing some of this in terms of the for alphabet, right? And what does that mean? That means, in a way, you can figure out how to compress the rest of this string, so that instead of having like 1,000 characters, you could compress it with. I don't really have a compression thing in my head yet, but in theory, you could represent it with in some way by just the fact that it has four alphabets, right? And in that case, it would kind of make the search space a lot smaller, or maybe not search space, just like the counting dynamic programming, the number of subproblems a lot fewer. Think about how that would work. Sorry, I'm just thinking a little bit. And I'm not giving. I think, yeah, I should articulate a little bit better. But I think one thing I'm playing around with is the idea that, or the question I'm asking myself is, does ordering matter? I think for each character in the beginning, maybe this isn't even right necessarily right, but the question is, okay, let's say you have a string that's huge. I think the problem I'm also having a little trouble with is kind of the some sequence could be duplicated, and how we factor that in. How do we? This is a tricky one. I mean, I think the more naive thing is for this, just can you memorize? I think the tricky thing for me is try to figure out how to do it in a way that doesn't double count some of these duplicate ones. And I'm not really sure that I can do it easily. And there are a lot of okay. Okay. Yeah, I think the tricky part for me is still trying to figure out how to remove the duplicates. Uh, yeah, because even just BCCB, right? I mean, you could just how do you not double count BCB? Because for me, I would probably do this CC something like some like X, something like that, and we'll have to figure that out. But in this case, this P I would probably usually double count, right? For one for each character. Uh, and this is and it's and you could even write up more complicated examples where BCCB, then you're gonna get this BCB sequence way too many times, right? So, huh. I think that the other way, just to be a little bit better at articulation, the other way I would think about it, and I was thinking about it, which I don't know how to kind of do convincingly, is it's kind of like almost like a build a reverse, build like a like a graph to kind of breadth first search to kind of add in the string, maybe in 1,000 it doesn't take that much, but I don't even know how. I don't think that's really that tractable, intractable. Anyway, I don't think that's possible just due to the huge amount of non-empty palindrome subsequences. Um, hmm. This is the thing where you and let me take a look at this. How would I solve that? Yeah, I think the little bit matter is that these problems are always a little tricky, and you can tell that uh, um, it's hard to kind of articulate in an interview if you're blocking. I mean, obviously, maybe the interviewer may give me hints, but in some cases, like hints would not be good enough. Maybe they'll be like, "Oh, remember, the alphabet is the size of the alphabet is 4," but it's hard to kind of either you get it or you don't sometimes, right? And I mean, sometimes it takes a long time to work through it, but it's hard to kind of see someone's thought process. So that and in a really biased kind of way, probably. Probably don't like this as an interview question as a result. Um, I mean, this only could be buffer search, but well, not buffer search, just string building. But so, okay. In the interest of time, I'm just going to cheat a little bit and see what the answer would give for this. 20. 3 billion. And this isn't even that long of a string, so. Can I rephrase this problem? Can we go from middle out? Sounds like I'm from Pied Piper or something, but okay. Well, assuming that it is a dynamic programming problem, then we will let's figure out the base case. Right? Base case is just empty string. I don't even know what that would be, but I guess 2. Okay, so maybe this is 1. So you see this. I mean, it is true, but maybe not that insightful. No, that's not true. Oops. So this is 2. This is 3. Which means this recurrence is a little weird. Because you could get P, C, B, C, B. Oh, that's not 3 then, also. Okay, so 4, is that right? So this one is using B, and then, CB maybe? Two, well, B and C. I mean, I think this one is the one that I'm actually not sure about. Because in theory, we double counted here with this one. Yeah, I mean, so I think for these problems, that's how I would kind of slowly reconstruct from base case just to, I mean, I use it as a last resort almost, but that's how I would kind of try to see if there's any insight into the structure of the problem that I can kind of think about. Yeah, B, C, B, C, B, 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 is this right? Yeah. Okay. So this represents C, this represents BCB. Wait, what did I say? No, this is also just really weird recurrence that I'm doing here. Because what you want is to your subproblems are actually because C is just, let's say this is this one, right? And I have a second C, it's in theory BCB, you just kind of wrap it around. But then how do you get B and B? Well, you can't even get BB. How do you get BB? In theory, that's baked into one of this F sub C, which has to use or use not. So maybe there's another dimension here, but that's also that. But that would make things. Maybe that's okay actually, because only one character could be in the quote unquote the middle. So you either you don't or you don't. So okay, so I think that also makes it so that maybe that's the missing piece. But it's still a little tricky to kind of figure out. Because in this case, I would have something like So I'm thinking instead of just this function based on one parameter, you need a second parameter where the second parameter is just whether you used you use the character as the middle piece, the single piece. That's in theory not too bad, but we have to figure out how to articulate that right. And also, there's some like weird. Like, how do you get from BCP to B? Maybe just this. Then I don't know. That's not quite as easy. So I think some of the easier dynamic programming problems is just different ways of kind of constructing things so that it's exhaustive, right? Like, you know, for me, it's if you tried all possibilities, and well, if you try all possibilities, it's easy to kind of figure out what the like you try them all. Like if it's an optimization problem or something like that. But in this case, because you're trying to count and it's clearly you can't even double count, it's a little trickier to kind of make sure you get some of them right. Like you can't just like in some cases where like let's say you're trying to get the max of something or the min of something, even if you say you solve the same subproblem a couple of times because max won't change, right? Because max of two numbers will always or like if you max the same numbers x time, like you'll still have the same answer, right? Where in counting, well then you're double or triple counting. So that's why it's a little trickier than usual, but to do kind of these kind of things versus I think definitely we definitely need a dimension of middle, which brings our size complexity from n squared still to n squared, but now we at least doubled it, right, in size. So yeah, but and actually maybe I'm debating changing it to language because but okay. I mean, all that said, still try to figure out how to do this a little bit. Um, so okay. Yeah, maybe just need to pre-compute it. Yeah, I mean, I think proving some of this stuff is kind of hard. I think we just have to. Is there a way I could do something exhaustive about it? And I think, man, this is I mean, I think the problem that this reminds me the most is kind of solving the number of, was it distinct subsequences, where, but man, and to be honest, I don't remember how to do it, or not. I mean, I have some idea, but it's been a while. Okay, I mean, I think what I need to do is kind of yeah, take advantage of the fact that it's 4 characters. How do I do that? Right. Okay. Is greedy good enough? No. Man. Okay. Let's say we have. I mean, okay. So we have. Let's dumb it down for me a little bit. Let's say we have only our alphabet is only 2 characters. What would change? Well, I mean, I guess my example already only had 2 characters, but I think I need to be slightly smaller than that. And I think maybe this is confusing me a little bit, but because as I say, we would probably I mean we would probably just use the indices. Okay, that's actually, in that case. Let me change to C so that stuff is slightly cleaner. Well, I wouldn't say cleaner necessarily, but make sure this compiles. Yeah, all right. Okay. Now let's say so the base case is that let me start from the beginning. Okay. Let me refresh my head a little bit or restart my head. Anyway, so my inclination is still going to be left and right. Let's say f of I sub I. That's the base case of 1 character. That's going to be 1. Let's say you have 2 characters. That's still 1, assuming that they're the same. I mean, that's fair. Right? Okay, I mean, otherwise, I mean, maybe. I don't even know if this is actually necessary, maybe. Question mark. Don't. But, so what is f of left and f of right is equal to, okay. Okay, well, let's just say, I mean, in the very basic one is equal to y minus 1 if s sub left is equal to s sub right. I mean, that's what we said before, where you chopped off the stuff at the end. If not, then it's oh wait, is that true? No, well, it's actually probably something like that. Again, this is I'm still trying to think about how to do, and it's been a while, counting the number of distinct subsequences in general, not relating to palindrome, though this stuff may add up. But okay, and if they're not the same, then what do we do? Well, I guess we just count the same amount, but plus, did I get it backwards? So someone like that, does that make sense? No, sorry. No, you minus this. Because I think this, maybe that's how you take care of the overlapping. I don't know why. Because you minus the stuff that's in the middle. Yeah, because I think if your side characters are the same, then you can just take one off and add it to the palindrome. And if they're not the same, then you have to subtract, because then some of these will double count. Okay, I mean, is that enough? So this, I mean, that's enough-ish for the number of distinct subsequences, maybe. But I think, or maybe not even distinct, number of subsequences. But now we have to factor in the now do we have to factor in the fact that it's duplicate, which is the part that I've had issues with. And how do we incorporate the alphabet? So since it's only 4 alphabets, can we alphabet or character? What does that equal to, right? Well, Man, I got kicked off the internet for a second. Oh, there's my window. So what does this look like? What does this mean? Um, well, first of all, this is equal to 1 if s of I is equal to character. Otherwise, otherwise it's just 0, I guess. And now this case will be I guess this is still the same. Actually, I think this one you still have to deal with the overlap. But how about this? If it is the character, then you have to say something like CCP. If the left is equal to right, then you just equal to me plus. That's fine. But now you have to. I guess you just do. And now you sum kind of the. You just kind of do the each letters of the alphabet probably, but. Is that right? Something like that. Okay, well, what does the character mean? The character means that this is already on the border with that character. So it has to. Number of. Sorry guys, I'm kind of having trouble with this one more than I am usually. Hopefully, well, I mean, maybe sometimes I'm always in trouble with it. Yeah. I think this part is right? If the character left. It's not you go to character right. So there's some weird bracketing things going on. Then you just keep the same character, but then you count the ones, and then you subtract out the overcounting or whatever it is. This, whatever the left is, you go to right. Then, then it's you go to. Oh, then I guess you could try all the possibilities, which in this case, because there's only 4 alphabet. So if this is the case, maybe you do something like, well, you minus the border, so then you do something up, and then A, and then etc. Towards last D. And then well, that maybe should be okay. That is this 1 or 0? Maybe. Oh, now the 1 will be here. Okay. Okay. Well. Sorry, I think. Sorry, I'll explain my logic a little bit. I think I kind of jumped a little bit from time to time. So I think so my logic was that, and maybe I should, like I feel like one of those supervillain given a monologue before solving the problem, so like it could actually totally be wrong. But I think my first intuition is to, what the hell? Is it actually streaming? Okay, I don't know. But my first intuition, one of the more recent intuition, is to kind of just count the number of distinct subsequences, which is how I got the first formula, kind of, and subtracting it. But taking advantage of kind of the character, which is which adds a dimension of kind of what, like what is the last character to be, or what is the number of distinct palindromic subsequences, given that characters the war, and then inside you could kind of figure it out, and if the two characters on the edge are not the same, then you either move on to the left or move on to the right, and then you kind of subtract the stuff in the middle. I mean, maybe I could draw a diagram, but you can imagine like, I don't know, but like, you have like a big thing. So this one ends up counting, let's say, this chunk, and then this recurrence will count this chunk. Or actually, I think I got them backwards, but you get the point. And then this chunk will kind of subtract out the overcounting from this chunk, because we overcounted that over there, and so that's if the two edges are not the same. And if they're the same, then we can just chop them off, and then and there are 2 ways to chop it off, right? One is to use the edges, like I was saying earlier, like if you say have say BCB, the 2 ways to, so that you could chop off the 2 B's, which is the C, which leads to something like C, but the answer would have essentially either BB or sorry, in this case it would either BB or BCB, or just C itself, because you chopped it off and then not use it, right? So your 2 possibilities are chopping it off and use it, or chopping it off and then don't use it. So those are kind of the things I'm So actually, maybe this is 2 then. We'll play around with it first. So that's kind of the way I would think about it. And now that we have this recurrence, all that's left to do is kind of code it up. This is, I'm gonna, yeah. I think one thing to note is that both left plus one and left is always going to be left plus one, and right is always going to be right minus one. So you can do something that takes advantage of that. Right now, I'm feeling a little bit lazy, so I'm just going to do it with memorization, and also I'm not actually to be honest, super confident about this problem. And in those cases, doing it with memorization allows me to kind of play around with the recurrence a lot easier. If I need to change the ordering even of how to do the recursion or something like that. How many alphabets there for? Something like that. What was that? 1,000? So, something like that. Yeah, okay. Yeah, I know, I didn't declare it. Yeah. That's a -1. That's a sando value. And then in this case, we just need to kick it off by using global for recursion. Not sure I recommend it for clean code, but for now, that's what I'm going to do. So go. And then you need the alphabet, so okay, fine. I'll write it out. Maybe there's a multiplication somewhere. Maybe I'm missing something. Maybe not. Okay, well then. Oops. And I'm going to screw this up with the number of zeros. All right, let's try that. Okay, so that part is okay. So let's say we want to implement all this junk. Oops. Yeah. This way. Just in case. This should be times 0. This is going to be a mess to read. Maybe it makes it slightly cleaner. Okay. Oh, I have to. This is subtraction. Okay, fine. I forgot about that one. How do I do this? Okay, well. I have to check the alphabet. I'm not 100% sure. We'll play around with this for a second. The automate. Should be okay. Yeah, okay. Hours. Yeah. Could be 2. Well, I guess I should use add one. Yeah. Okay, fine. Oops. Something like that, maybe. Right, let's see it compiles first. Oops, I knew that. I was thinking about it when I was typing it, but forgot. Oops. Too used to Go, sometimes I forget semicolons. Okay, at least it works. I mean, well, It compares, I mean. Okay. Yeah, let's try this easier case first. So back to the basics. Okay, so I'm double counting something for sure. Okay, how would I get 8? Well, 8 is just 2 to the 4. No, 2 to the 2, no. How do I get 8? That's a good question. Well, one other thing I need to do but totally forgot, and somehow it still runs in time, is memorizing stuff. We add that in first, even though it's still wrong. Okay, so at least it's consistently wrong, which is all you can ask for sometimes. For now. Take this out. No, yeah. I guess this is supposed to be an int, not, but okay, fine. There's some weird stuff about casting possibly, but well, we'll see what happens. Oh man, always forget. Am I double counting the alphabets? Seems like it, because why does the alphabet, why do I do 3 alphabets? Okay, fine. Maybe my kickoff is a little wrong. Let's double check some stuff. This should not count for 4 times. Probably not. It should only be giving me a results something subset of the times, but no, I need to check for alpha here somewhere. No, whoops. Well, that's not quite right. Oh, plus something like that. Okay, well, How did that happen? Oh, because more of these are doing this. But yeah, I think I got these backwards. That's why. And where's my cup? Well, I guess I'll look at the logs, but this doesn't make sense. Because if they're the same, then we could chop them off. Otherwise, then we do that overlapping thing. Yeah, I know there's some double code here, but okay. I mean, it's not right, but at least it undercounts, which is good. Maybe I don't know. Okay. And the one thing that I thought maybe here is because you have to chop it off, and the two possibilities. So let's play around that. So I think that's the thing that I had some doubts about. Base cases are hard. Well, okay. I mean, this seems to be right, but I mean, anyone could be right on one problem. So let's try this other way. I mean, one test case rather. Okay. Maybe we should try this easier one first. Okay, well, I don't know how that worked, but okay, well, let's try some empty strings and stuff like this. It's too magic for me, to be honest. Oh, okay, well, fine. Well, at least it's wrong. And I caught it beforehand. Ha ha ha. But what is this? They should return one once, right? So 1, 3. Oh, dumbass. How did this even... man, how did I get this big thing right if... It is way... was I even right? Okay, I mean... Like, maybe it's off by some stuff that wasn't... Oh, man. That's what I mean sometimes. I don't... okay. When you get things right by accident, you still want to know why. Huh. Okay, well, I mean, I'm a little tired right now. Let's just submit and then see what I get wrong on. But, okay, well, I don't even know what to say. Sometimes you just get things right. But, okay. Yeah, I mean, so this took way longer than I really wanted to spend on this problem, to be honest. But yeah, I think so. We added the extra dimension because so that we can kind of make sure that I mean, I think really much earlier we were talking about kind of building strings kind of in a distinct way, and kind of keeping the character is allow us to kind of make sure that at each time that's the number of that's like the how do you say this because you're only counting each possible pairs of or on the edges of characters once. That's how you gotta keep it distinct. I'm not probably not saying it quite right, but you could think of it like yeah. I mean, I don't know. This is kind of tricky, but hopefully it helps me work on next time, and that's the alphabet part. but and that's why we keep on practicing a little bit. And but I mean, I think each of the components makes sense. It's just that I'm really rusty and slow in putting them together. I think so. So how I would improve this code? I mean, this is the standard memorization code. The tough part in dynamic programming problems is not really the coding per se. It's always in kind of the construction of the recurrence. And in this case, you can note that left will always only go, well, the left will only go right and the right will only go left. So you could build things kind of based on the fact that you only use the previous row in the matrix that way, and then you could from that you could construct the recurrence to build a dynamic program in a dynamically programmingly way. But so there's some optimization there to create, but I think this is actually easier to understand. As an interviewer, I think I mentioned it earlier. I don't like the problems like this only because there's some gotcha. I mean, it's not really a gotcha per se, but it's, there are a lot of dynamic program problems, and some of them has like a little bit of insight that it's just such a huge advantage if you've kind of seen it before. So, and it doesn't really usually help me think about like it doesn't let me see how the interviewee thinks about a problem. So I don't really like this problem for that reason. And especially with combinatoric stuff, it's sometimes tricky if the recurrence is not like straightforward. Like in this case, it takes advantage of this bound, which is the size of the alphabet, which like maybe if you already understand why certain things are distinct and certain things are not, then it makes things a lot easier, which is not something that, I don't know, it's a little tricky. But, and like I said, definitely I'm a little biased in how long I took it. Maybe if I have worked on this like 5, 6 times, then it would have been okay. But like with enough practice on similar problems, but even then, I just don't like these kind of problems, which requires like almost like a light bulb moment where you're like, oh, I got this. Where other things we're like, well, you know, certain constraints forces you to think a certain way, and then maybe that's okay. I don't know, but I mean, it does earn, I guess, for me anyway, that it is a hard problem. I probably, in a post-mortem kind of way, I probably should have think about it in terms of distinct subsequences a little bit earlier. I think I was probably playing with the idea of kind of first principles a little bit too much, and try to like derive it from that way. But I think as a result, my explanation for this problem is probably a little hand wavy if you haven't got the distinct subsequence problem before.